All right. So number four, it's a good example to walk together, because last example we have the 2x, but now not only we have 2x, we have 2x minus 2. Remember, whenever we have something in front of x, and then you also have something added or subtracted to each other, what should we do? We should always factor it. Okay, like you ask yourself, is it really tempting to say it has been shifted to the right by 2 units? It's really tempting, right? But there's a 2 sitting in front of x. So by that, you always remind yourself that please factor. So there are 3 transformations right here. So first, there is a horizontal compression by 1/2. There's a shift to the right by not 2, but 1. And then there is also a shift up by 3 units. Okay. So again, whenever you see a number sitting in front of x, take special precautions. Okay, take special precautions. So we say, all right. So let's go ahead and do our asymptotes first. So it's shifted to the right 1 unit. So our new vertical asymptote would be x equals to 1. Okay, we are shifting the vertical asymptotes to the right. Of course, because if you're not, then we don't know what it is. You just put a number. These are lines. These are lines. Okay. So horizontal asymptote, we say shifted to the right by, well, shifted. Oh, sorry. Wait, hold on. Yeah, shift to the right by 1 unit. So vertical asymptote got shifted to the right. And then we shift up by 3 units. So horizontal asymptote got shifted up by 3 units. So it becomes y equals to 3. Okay. So when these 2 asymptotes meet together, we have 1, 3 as the center of rotational symmetry. Okay. How about we go ahead and write down the domain and range at this moment, because we have the asymptotes already. So we're saying that x is everything but +1. Everything but +1. The range is everything but +3. Okay, so those. All right, now we are down to the pretty challenging things, such as the x and y intercepts. So now, again, let's go ahead, write down something that we know already. Okay, let's write down something that we know already. So we have some good guidance. We know that x-intercepts, the y is always equal to 0. For y-intercepts, the x is always equal to 0. Let's go write it down. That's this doesn't take much mental power to accomplish here. Okay. So now talk about the graph. So again, originally, we have these 2 points. Originally, before any kind of stretch or compression. But we do have a horizontal compression by 1/2. So we have to move 1/2 unit closer to the asymptotes. That's how it's being compressed. So make sure you show those 2 dots very clearly. And then make your best effort. Draw slowly. and show how the graph is leaning toward closer to the after the point. Yeah, so it's lean towards the asymptote. Lean towards the asymptote. I mean, it should be leaning like slanted a little bit. I mean, pretty steep. I mean, technically it's a curve. Technically, it's a curve. It's not a straight down line. Okay, it's leaning closer and closer, ever closer, but somehow they would never touch each other. Okay, like if you can somehow zoom in, you will see the curve. So we do see x and y intercepts based on the graph here. So let's go ahead and find out the y-intercept first. Y-intercept is a lot easier because we just have to put in 0 into x. So 1 over 2 times 0 minus 2 plus 3, which is negative 1/2 plus 3, which is, well, negative 0.5 plus 3, it's, oh, hold on, no, that's the y-intercept, right? 2.5, 0, 2.5. That's a y-intercept, 0, 2.5. Okay, 0, 2.5. And now, speaking of the x-intercept, so what you can do, like what we did earlier, you can actually make a common denominator, right? So you can do this, or actually, no, hold on. We can use the original. Oops. Let's go ahead and use the original. So we say 1 plus 1 over 2x minus 2 plus 3, and then you do times 2x minus 2 over 2x minus 2. That's how you do the common denominator. Okay, so you have 2x minus 2 for the denominator, and 1 plus. Okay, now make sure you distribute the 3, so you got 6x minus 6, which is 6x minus 5 over 2x minus 2. So that's how you combine the two terms together. You have a single fraction. And since we want the y to be 0, so that means this numerator will be 0. So if this numerator is to be 0, what's the x value? It'll be 5 over 6. Okay. So you combine the fractions, and then you combine the fractions, and then you set the numerator equal to 0, because for a fraction to be 0, the numerator must be 0. Okay. And you look at the graph. I mean, that looks pretty close to 5 over 6, right? So it's pretty close to 1. It's more than 1/2. So that makes sense. All right. So good. All right. Now, for one last one, which is number 6.